Good morning, student. Today I will teach you how to find R and S nomenclature in a chiral molecule without asymmetric center. Chiral molecule without asymmetric center. Okay, so here first of all question is that what mean by the asymmetric center. So asymmetric center, it is nothing but it is the chiral center. So we all know about the chiral center, that is any carbon which is attached to four different group is known as the chiral carbon, and that center is known as the chiral center or asymmetric center. Suppose I am giving one example. So suppose carbon is attached to the one is methyl group, one is Br, suppose one is OH group, one is hydrogen, right? And we want to find out which configuration is over there, either it is R or S. So according from CIP rule we can find R and S. That is first of all we have to give the priority in a functional group having high atomic mass. So first of all, here carbon is attached to the oxygen, here it is attached to the bromine, here it is attached to the carbon, and here it is attached to the hydrogen. So we have to give the priority. Br first one, OH second one, methyl group is third, and hydrogen is fourth, right? Okay, so after then we have to rotate 1 2 2 2 3, and if it is clockwise, then we can say the configuration is R, and 1 2 2 2 3 ignoring 4, if arrangement is anti-clockwise we can say S. But condition is that fourth group must be vertical, right? And if fourth group horizontal, then R become S and S become R, right? Okay, so I will explain you what mean by this one. So see here, arrangement 1 2 2 2 3, we can say this is the 1, this is the 2, this is the 3. So 1 2 2 2 2 3, the arrangement is we can say clockwise. So first of all write, if it is clockwise then it is the R. Then next one we have to see the position of fourth group. So fourth group must be vertical, then and then it is R. So here we can say fourth group is at horizontal, it is not at vertical position. So if it is horizontal, then R become S and S become R. So here we can say R become S. So this chiral carbon has S configuration. So by this way we can find R and S in a chiral center or asymmetric center. But here I will teach you chiral molecule without asymmetric center. So we cannot see any asymmetric center, then even if it is considered as a chiral molecule. So one by one I will give the example. So their example are, first one is Allene system, next one Spiro compound, we can say third one Adamantine, fourth one is Biphenyl system, Next, Ansa compound, paracyclophane, and last one is helical compound, right? So there will be total 7 compound, 7 chiral molecule. Okay, so here there will be 4 type of chirality, 4 types of chirality. First one is central chirality. Second one is axial chirality. Next, planar chirality. And fourth one is helical chirality, right? Okay, so here this is, we can say, central chirality, because there will be chiral center. So this is the example of central chirality. Now axial chirality, Allene system, Spiro system, Adamantine and Biphenyl system. This fourth compound shows axial chirality, right? Ansa compound and paracyclophane has planar chirality, and this helical compound has helical chirality. Second one thing is the adamantine molecule is also shown central chirality. I will give one example, central chirality. Okay, so this is the basic chirality, central chirality. Now I will explain you in detail about axial, planar and helical chirality. Okay, so first of all I will start with Allene system. So first of all, what is the condition for Allene compound? So condition, first one is it has 2 double bond, we can say even number of double bond, condition number 1, right? Condition number 2, suppose I am giving one example, carbon double bond. So here we can say there will be 2 even double bond, right? Okay, so now suppose this is the A, any functional group A, this is the any functional group B, this is the C, functional group C, and this is the D, right? Okay, now here we can say the A and B both are in plane, because I have mentioned in plane. This is the below the plane, C functional group is below the plane and D functional group is above the plane. So for Allene system arrangement is like this. There will be 2 functional group are in plane, third one is above, below the plane, and fourth one is above the plane, and even number of double bond. And second condition is that A is not equal to B and C is not equal to D, right? A is not equal to B and C is not equal to D. First one is it must contain even number of double bond. Second one is that their functional group A is not equal to B, C is not equal to D. Okay, so one by one I will give you example. Suppose first example. Okay, now suppose carbon double bond, carbon double bond, carbon, right? Hydrogen, this is the hydrogen, this is the hydrogen, and suppose this is the chlorine. So first of all, we have to check either this compound is chiral or not. So for chirality, this is the condition for chirality, right? Condition for chirality. First one is it contains even number of double bonds. So this condition is satisfied. A is not equal to B, C is not equal to D. So here we can say A is equal to B. So this is not chiral. That is achiral. This molecule is achiral. The molecule is chiral only and only if it has even number of double bond and this condition, right? So we can directly tell that this is the achiral, right? Now next example. And if it is chiral, then we have to find either R or S. Suppose second example, carbon double bond, carbon double bond, carbon. This is the Br, hydrogen, and chlorine, right? So first of all, either this is chiral or not. So it has even number of double bond. A is not equal to B, C is not equal to D. That is, we can say this molecule is chiral. If the molecule is chiral, then and then we can find either R or S. This is very important sentence. If the molecule is chiral, then and then we can find either it is R or S, right? So this is the chiral. So we have to find R and S. So I am giving some rules. So note down in your note. So first of all, Allene system, we know that it has chiral axis. So this is the chiral axis. So chiral axis is this one, right? So it will pass from central 3 carbon, right? Starting from, okay, so here we can say this Br and hydrogen are plane. So we have to start chiral axis from plane and ending to out of plane or below the plane, right? So first of all, chiral axis is passes like this. Then give the number. So how to give the number? So first of all, we have to start the numbering from planar system. So Br, so this is in plane. Br and hydrogen are in plane. Hydrogen and chlorine are not in plane, right? So we have to start from this. Now Br and hydrogen. So Br has higher atomic number. So higher atomic number we have to give first priority, right? Then hydrogen, right? So starting from plane system. Okay. Now ending to above and below plane system. Now think about hydrogen and chlorine. So chlorine has higher atomic number. So give number 3 to chlorine and give number 4 to hydrogen, right? So don't think that Br is a higher atomic mass. So first one is this, chlorine is this. That is only possible in the molecule having chiral center. This molecule is chiral axis. So we have to give the RS nomenclature like this one, right? After then same rule, 1, 2, 2, 2, 3, rotate clockwise. If it is clockwise, then it is R. If it is anti-clockwise, then it is S. But condition is that fourth group must be below the plane. Here fourth group is below the plane. Okay, so here we can say 1, 2 and 3. So starting from 1, 2 to 3, 1, 2, 2 to 3. So it is clockwise. So it is R. But condition is that fourth group must be below the plane, or one can say fourth group must be vertical. So here fourth group is below the plane. So R become as it is. So its configuration is R. It is a chiral and having R configuration, right? Okay. So another example I will give you. So suppose third one. Suppose this is your molecule, carbon. Molecule is like this one, right? It has methyl group, another one is chlorine, sorry. Now third molecule, suppose carbon, double bond carbon, double bond carbon, methyl, chlorine, CH2SH, and fourth one is hydrogen, right? Now we want to find out R or S over here, right? So first of all, we have to start axis. First of all, we have to either it is chiral or achiral. So for axial chirality, it must contain even number of double bond. Okay, there will be even number of double bond. Next one is A is not equal to B, B is not, C is not equal to D. Okay, so it is chiral molecule. This is the chiral. Now either it is R or S. So chiral axis is observed. So it will be passed from the plane. So this both functional group are in plane. So chiral axis starting from plane to ending to this one, right? So in previous example, whatever I explained you. Okay, now give the number. Now chlorine and methyl. So chlorine has higher priority. So it is 1. Methyl has 2, right? Now CH2SH. So here carbon is attached to carbon. Here it is attached to hydrogen. So it is given number 3 and this is the number 4, right? Now rotate 1, 2, 2, 2, 3, ignoring 4. So 1, 2, 2, 2, 2, 3, 1, 2, 3. So it is, we can say, clockwise. So configuration is R. But condition is that fourth group must be below the plane or vertical. So here we can say fourth group is at vertical. So R become as it is R. So its configuration is R. I hope you understand, right? Okay. Next, fourth example I will explain you. Right? You can do yourself also. Carbon double bond, carbon, CH2OH, and next one is CH2CH3. Okay, we want to find R or S over here, right? So first of all, it has even number of double bond. A is not equal to B, C is not equal to D. So it is chiral. So first of all, you have to find molecule is chiral or not. If it is chiral, then and then you have to find R and S. Otherwise, for achiral molecule, you can't find R and S. Right? Now, chiral axis passing from the planar system. So this is the planar system. So this is the chiral axis. Right? So give the number starting from the chiral axis. So this is deuterium having higher atomic mass. So it is 1 number. And this is the 2 number. Right? Now here carbon is attached to the carbon. So carbon, two hydrogen. After then it is attached to oxygen. Here it is attached, this carbon is attached to the carbon. So oxygen has higher atomic mass number than carbon. So it is given number 3. And this is the given number 4. Right? Now rotate 1, 2, 2, 2, 3. So here we can say 1 number, 2 number, 3 number. 1, 1, 2, 2, 2, 3. So it is anti-clockwise. So we can say configuration is S, right? If only provided only if the fourth group is below the plane. Here we can say fourth group is not below the plane, it is the above the plane. So R become S and S become R. So we can say S become R. So its configuration is R. So by by this way we can find out um, RNS nomenclature in the Allene system, right? So suppose I am giving to another example to you, fifth number, right? So example, carbon double bond carbon, sorry, fifth number, okay. So first of all we have to check either your compound is chiral or achiral. So it must have even number of double bonds. So see here there will be odd number of double bonds, so it is not chiral, we can directly tell it is achiral, right? So we can't find R and S over here. Okay, next example, okay. So here we can say it is not even number of double bond, so we can't find R and S, so it is achiral. So we can say this is the trans, right? Or one can say it is trans also. They are geometrical isomer. Cis and trans are geometrical isomer, or one can say diastereomer, right? Okay. So it is achiral. Why? Because there will be no even number of double bond. So I hope you understand about the chirality in the Allene system. Okay. Now next I will teach you about the chirality in the Spiro compound. Second one is Spiro compound. So Spiro compound has also axial chirality, right? So condition is as it is same. Here condition is even number of ring, right? Or one ring plus one double bond, right? Okay, so I am giving you one example to you, right? So in previous example I have teach you about carbon double bond carbon, right? So suppose this is the A, this is the B, right? Suppose this is the C and this is the D, right? So it has even number of double bond and A is not equal to B and C is not equal to D, then that is the chiral molecule. So same here as it is, there will be, instead of this carbon double bond carbon, you have to put ring over there, right? So suppose I am writing carbon, right? So sorry, I can write over here also. So suppose instead of this double bond, if I put here ring, right? Spiro ring. So this is the chiral molecule. So I have erased this carbon double bond carbon, right? This carbon double bond carbon, and instead of that I have write Spiro ring, right? This is the Spiro compound. Okay, or this is the Spiro. Or another example you can give, suppose carbon double bond carbon, I am writing over here A, B, C and D, right? Now instead of this carbon double bond carbon, only one carbon double bond carbon, if I put Spiro ring, one Spiro ring, right? So condition is that A is not equal to B and C is not equal to D. So this is also Spiro compound, right? So even number of ring or one double bond and one ring. So total must be even. Okay. So same we can find R and S same in previous example in Allene system. That is, first of all, I am giving one example to you. Suppose right, another Spiro ring. This is the methyl, hydrogen, fluorine and chlorine, right? So same, first of all we have to check either it is chiral or achiral. So we can say there will be even number of ring, Spiro ring, and A is not equal to B, C is not equal to D, so it is chiral. Then we have to find which chirality is present here. In Spiro compound there will be axial chirality. So we have to start axis from planar system. So this is the planar system. We have to start planar system to this one, right? And give the starting numbering from the planar system. Fluorine and chlorine. So chlorine has higher atomic mass, 1, 2. This is the methyl 3 and this is the 4, right? So 1, 2, 2, 2, 3 clockwise. So it has R configuration, right? Condition is that fourth group must be below the plane. So this condition is satisfied over here. So it has R configuration, right? So suppose I am giving another example. So system is like this. Chlorine, CH2SH, this is your deuterium and this is your hydrogen, right? Okay, so first of all, even number of ring, A is not equal to B, B is not equal, C is not equal to D. Now starting from planar system to this system, deuterium has higher atomic mass, 1, this is the 2, right? Now CH2S, so it is attached to carbon and this carbon is attached to chlorine. So chlorine has higher priority. So this is the 3 and this is the 4. So 1, 2, 2, 2, 2, 3 anti-clockwise. So it has R. So provided if fourth is below the plane. So here we can say fourth is below the plane. So as it is, S become S. So this is S configuration. Okay. So this is about the Spiro compound. Now next one is the Adamantine. Third one is Adamantine. Adamantine has also axial chirality plus central chirality. Okay, so first of all I am giving one example to you. This is the Adamantine system. You can draw like this one. Okay, suppose molecule is like this. Suppose it is suppose methyl group. Over here it is hydrogen. Over here it is chlorine and here hydrogen. So you can observe over here uh, chiral axis, one of the chiral axis, right? Methyl hydrogen, chlorine. So these both are in plane. These are above and below plane. So chiral axis starting from the plane to ending to this one, right? So Spiro compound is, you can draw like this one, and if the atoms are attached to like this, then you can say it is adamantine system, and it is chiral. So if it is chiral adamantine, then you can find R and S, right? So same, methyl is higher priority 1, and this is the 2, this is the 3 and 4. 1 2 2 2 2 3 clockwise, so it must be R, provided if fourth is below. Here fourth group is below, right? So it is R. So here we can say here there will be axial chirality is observed. You can't tell that it has central chirality. Okay, so I am giving example of adamantine system, another example in which central chirality is observed. So first of all, draw adamantine. This is the adamantine, right? So if adamantine, right? Okay, now suppose one functional group is present, suppose here Br, right? Here another functional group is present, deuterium. Here another one is chlorine, and another one is suppose hydrogen. So you have to write one functional group over here. After left after one carbon you can write another functional group. After one carbon another functional group, and after one carbon you can write another functional group. So suppose you think that this adamantine is carbon, you think that instead of adamantine this is the carbon, right? This is the carbon. So you can say carbon is attached to 4 different group, right? Br, deuterium, chlorine and hydrogen, right? So it is central chirality is observed over here, right? So here you can say this molecule is chiral and it is central chirality, right? Okay, so you have to think that this fourth group is okay. So here first of all you have to tell 1 2 2 3. So bromine has first priority, right? This is the chlorine has second priority, and deuterium has third priority. So 1 2 2 2 3, that is it has as configuration. Condition is that fourth group must be below the plane. Okay, so here what is the position of fourth group over here? So first of all suppose I am drawing fourth group over here, right, like this one, hydrogen. So here you can say fourth is below the plane. If hydrogen is like this, then this is above the plane, and if hydrogen is like this, then it is the below the plane, right? So suppose I have drawn hydrogen like this one, so it is the below the plane. Then you can say S become S and R become R. So here the S configuration over there. So this molecule is chiral and having S configuration, right? Okay, now I will explain you about next system, biphenyl system. Fourth one is biphenyl system. So first of all, biphenyl system, that is there will be 2 phenyl ring, right? One is this one, suppose another one is this one. This is known as the biphenyl system. So suppose we have to tell either this molecule is chiral or achiral. So this molecule is achiral. Why? Because there will be plane of symmetry present over here, because both benzene ring are in same plane. Okay, so for chirality, what is the condition for chirality in biphenyl system? So this condition is that first one is arrangement. There will be no plane of symmetry, absence of plane of symmetry, absence of plane of symmetry, right? How plane of symmetry becomes absent? Because if one is in plane and one is, if you draw like this one molecule, draw like this one, right? That is, we can say this is the plane, first benzene ring, right? Another one is like this, so we can say both are perpendicular to each other, right? So half of the phenyl ring is above the plane and half of the phenyl ring is below the plane. Then and then there will be no presence of plane of symmetry, right? Now next one is second one is proper substitution. Proper substitution, right? That is bulky group present at ortho position. And consider hydrogen, fluorine and deuterium are not bulky group, right? Okay, suppose I am thinking this is your molecule, right? So suppose this is the A, this is the B, and this is the C, and this is the D. So molecule bulky group are present. So minimum 3 bulky group are present. This is very important. Minimum 3 bulky group at ortho position. At ortho position, right? So these are ortho position. So here we can say A, B, C and D, in which at least 3 group must be bulky. Okay, so only one hydrogen, one fluorine or one deuterium is present. Minimum 3 bulky group are present. And third condition is that as it is, A is not equal to B and C is not equal to D, right? So this is condition for chirality. Condition for chirality, right? So I will explain you by giving example, right? So first of all, example number 1. Suppose you have to give one sorry SO3H, and this is the methyl, right? We have to find either first of all molecule is chiral or achiral, and another one is this ring is above the plane and this ring is below the plane, right? Second, you can understand it is the below the plane. Okay, right? So this ring must be below the plane. This is the above. So first one is there will be no plane of symmetry. Second one is minimum 3 functional group are bulky. So SO3 is bulky, methyl is bulky. So here we can say 4 all group are bulky. So there, and third one is A is not equal to B and C is not equal to D. Okay, so now we can start as it is. Numbering start from the planar system. So this is the planar system. Now SO3H and CH3. So SO3H is given number 1, this is the number 2 and this is the 3 and this is the 4. Now starting from 1 2 2 2 3, so we can say 1 2 2 2 2 3, that is anti-clockwise, so it must has S, right? But condition is that fourth group must be below the plane, right? So here we can say fourth group is methyl group, so it is below the plane, so S become as it is S, right? Now this is the order of bulkiness, order of bulkiness. So bromine has higher bulkiness than methyl, is higher than chlorine, is higher than NO2, is higher than COOH, right? Is higher than OCH3, and chlorine, hydrogen and deuterium. So they are not bulky. We can say that they are not bulky, right? We are not consider fluorine, hydrogen and deuterium as a bulky group. Okay, now next example about the biphenyl system. So this is the okay. Now first of all, these both are the plane of symmetry is not present, right? Second one is at least minimum 3 bulky group. So see, SO3H methyl group are bulky, but deuterium and hydrogen are not bulky. So here there will be no at least 3 minimum functional group must be bulky. So here there will be no bulky group, 3 bulky group are present. So it is achiral. So there will be no necessity to find R or S, because we can't find R and S if the molecule is achiral, right? So this is about the biphenyl system. Another example, suppose I am giving you, right? Right? So okay, first of all, okay, this is the above the plane. Now there will be no POS. All group are bulky group, so that condition also satisfied, right? A is not equal to B, C is not equal to D. Okay, so chiral axis is present. So starting from planar system, right? This is the chiral axis. So give the number. This is the 1, right? This is the 2. Now bromine has higher priority, so 3 and 4. So 1 2 2 2 3, that is clockwise, so it has R configuration, and fourth group is below the plane. So see, this group is above the plane, so this must be below the plane, so R become as it is R, so it has R configuration, right? Next example I will give you. Okay, so first of all, now there will be POS, at least 3 function group must be bulky, so 1 2 3 are bulky, right? And A is not equal to B, C is not equal to D. Okay, Now chiral axis starting from planar system. So starting from planar system, right? You consider is a straight line. Okay. So Beer has 1 number, COH 2 number, this is the 3 number, and this is the 4th number. So 1, 2, 2, 2, 3 anti-clockwise, right? So it has S configuration, but condition is 4th must be below the plane. So see here 4th group is above the plane. So R become S and S become R. So S become R. Okay. So now next one I will teach you about the chiral plane and another helical system. So up to this I have completed chiral molecule having chiral axis. Okay. So 4 molecule I have explained you, that is Allene system, Spiro system, Biphenyl system. Sorry, 3 molecule I have explained you. Okay.